So in this video we're going to look at applications of differentiation to families of functions. And what that means is functions that are going to contain parameters, so things like y equals a plus x times x plus b all squared. The a and the b, they're parameters. Sometimes they'll give us some definitions or some information about the size of a and b, whether they're positive or negative numbers. So this information is telling us that both a and b are positive numbers because they're greater than 0, and that b is greater than a. So far, working with parameters, we've talked about parameters as being in terms of function transformations. So we've got the parameters y equals m as a parameter, x plus c, as our transformations of our linear function. And so you can combine the idea of function transformations with differentiation with respect to x for functions with parameters to help you to solve problems, and talk about that a little bit more in a sec and make it clearer. But what you need to remember is if you're differentiating something with respect to x, so d dx of whatever it is, whatever you're differentiating for, differentiating with respect to x, you treat all of the other parameters as constants. I know that they're not actually constants, and that's how you get your family of functions, but when you're differentiating, you treat it as a constant. So this m here is multiplying the x. So if we find the derivative with respect to x of this function here, this is your coefficient of x, and when you differentiate this, you just get an m. For this function here, again, we're going to differentiate with respect to x because that's what that little x says here. And this is a function we're going to differentiate. So we use our derivative pattern on what we've got here. And so we're differentiating with respect to x. So this is e to the constant x. So we use our derivative formula for this. So the m is going to come out the front. So 3m e to the m. Oops, that should have a little x with it. There. And then we use our derivative pattern on our power function here. So the m is going to come out the front. So minus 2m. And then the m drops in power by 1. So you get this m minus 1. So when you're differentiating with respect to x, treat all of the pronumerals as constants. The other thing you need to be careful of if you're working with families of functions or you're working with pronumerals is to make sure that you're not doing calculations with pre-existing values of pronumerals from like a to m. So there's different ways that you can make sure that that's the case. So if you don't want to create a new document which starts all of the variables as a clean slate or a new problem, then you can clear all your variables using your menu button actions and clear all variables. Any one of these gets rid of any stored values for variables, and then you can work your way through. If you don't clear the variables and you've got a value, say for m in this question here, when you find your derivative, you won't get a formula, you'll get something with values in it. And that'll give you an idea that you've got it wrong. So let's look at some questions. For the family of functions with the rules of the form f of x is equal to x plus a times x plus b all squared, where 0 is less than a is less than b, find f dash of x. So we're going to do the derivative with respect to x. We're going to find the coordinates of the stationary point. And if the function is translated c units to the right and d units up, what are the coordinates of the stationary point? So we're going to do some translations of our stationary points. So let's go through and to look at our answers. So the first thing we need to do is to find the derivative. And the function that we've got is two functions multiplied together, two linear functions. And this is a linear inside a power function, so we're going to need to use chain rule for this. So if we go ahead and differentiate that, which is what I've done here, take out common factors and pull things together. So I'll let you pause and have a look at what I've done here. So I've used the product rule for this. I would only go through and do this by hand if it was exam 1 where I don't have access to my CAS calculator. If I had access to my CAS calculator, I would simply get the CAS calculator to do it for me and write the answer that my CAS calculator gives me. Making sure that when I write the answer, the CAS calculator is not going to remind me that I actually need to put f dashed of x at the front. Don't just write the expression. Okay, if you're asked for f dashed of x, write f dashed of x is equal to. Okay, part B, we needed to find the stationary points. Now, for the stationary points, we need the derivative to be equal to 0. So we let our function equal to 0 and we solve from there. That doesn't get us our full stationary points. That gets us our x values where the stationary point occurs. So to find the actual coordinates of the stationary points, we need to substitute this value back into the original function up here. And the same with this one, it needs to be substituted in. And again, unless this was exam 1 and I wasn't able to do this using my CAS calculator, I would simply do this using my CAS calculator, which is what I've done over to the side. So you can see here, excuse me, that what I did was I defined the function so that I could find its derivative. I could then solve the derivative equal to 0. And the only reason I found the derivative first before I solved it was because the question asked me for the derivative. And if I just put d dx of f of x equal to 0 in here, I wouldn't actually get to see the derivative function. So that's why I did the derivative function first. So these are my x values that give me the stationary points. Substitute one into f and then the second one into f. And that's how I got my coordinate points that I got over here. And then finally, we need to move the stationary points, c units to the right. Okay, so that's going to change our x values from x to x plus c. And d units up, so it's going to change our y value to y plus d. When I do that with the 2 points, this is what I get. Minus b plus c, 0 plus d. You can tidy this up if you like. And unless I was asked for a specific format, I would just leave them as they are. Let's have a look at another one. So in this example here, we're going to look at a cubic equation that's got the rule ax cubed plus bx squared plus c, and it has a stationary point at 2, 5. We need to find a and b in terms of c. So we're going to find two unknowns, which means we're going to need to find two equations to solve. Two unknowns, two equations. And then we need to find the value of c for which the graph has a stationary point at x is equal to 3. Okay, so let's find those two values of a and b. Like I said, to find a and b, we need two pieces of information, we need two equations. So we know that 2, 5 is on the line, and the 2, 5 are our x and y values, so that's x and that's y, and so in our equation y equals a x cubed plus b x squared plus c, we make our y 5 and our x's are 2. That gives us one equation. We also know that the stationary point has a derivative equal to 0, and that occurs when our x is equal to 2. So we take our derivative formula, let it equal to 0. So 0 is equal to 3x squared, and our x is going to be worth 2, plus 2bx, and our x is worth 2. And then we're going to solve those. So what I've done is I have also gone and solved this using the CAS calculator simultaneously. And so I want to bring this up so that you can see what I've done. So we're going to define our function first of all, because I'm going to use it multiple times, and then I'm going to find f of 2 is equal to 5. So f of x is equal to y. So that's our first equation, which is this one here. And then I'm going to solve that the derivative of the function, so the derivative of f of x is equal to 0 when x is equal to 2. When x is equal to 2. So this line here is the given that line. So what I've got in this bit here is the derivative, let me just bring this up a little bit more, is that the derivative of y with respect to x is equal to 0. So this bit here is that bit there. Then I've got this given that line here, which is that given that line there, and then x is equal to 2. Now you can see that I've solved this for just a and b rather than a, b and c as my variables. And so I've got an answer as a in terms of c and b in terms of c, because it's got a c in it. If I did it with having the c in there as well, and I've done that just below this one, what you get is quite a different answer. Your calculator gives you an answer that has its own constants in it. It's a bit of a weird thing to do. So it gives a new parameter for a, b and c and writes all of those parameters in terms of its new one. So you can see here that it's given a is equal to c1 minus 5, b has got a c1 in it, and c is equal to c1. And if you replace all of the c1s in here, so if you replace this c1 and this c1 with just a c, you get exactly the answer up above, which is what you need to do. So in the exam, you shouldn't be writing c is equal to c1. c1 is considered to be, your calculator is trying to tell you that it's constant 1. Now, normal mathematical practice will tell you that you don't write c1, c2, c3. What you'll use is another variable, and normally you'll use something like lambda or another, so this is the Greek letter lambda here, this one, or you can use k or another variable. Okay, but don't use your constant ones. Now, the reason you get C1, C2, and C3 is every time you need a constant, your calculator will use the C value and the C letter, and then just increase the number by 1. So the first time you'll get it, you'll in a document, you'll see C1. The second time you have an extra constant, it'll say C2. The third time it'll say C3. Okay. Final thing that we needed to do was to find the value of c for which the graph has a stationary point at x is equal to 3. Now I'm going to do this wholly and solely on the calculator, and I've already done it, so let's have a look at what I've done here. So what I've asked for is this is the function with our a value in terms of c, see our a values in terms of c, our b value also in terms of c, and of course our plus c. Then I've asked it to solve, so we want the stationary point to be at x is equal to 3. So I've got my given that x is equal to 3 here, and so we need the derivative equal to 0 when x is equal to 3, and I've asked it to solve all of that for c for me, and it tells me that the answer is 5. This last question comes from the 2018 Northern Hemisphere paper, exam 2, so we have a CAS calculator to help us, and it was actually question 4. So let's have a look at the question. For f greater than, for positive values of f of x is x minus x log to the base e of x. Okay, find the equation of the tangent to the graph of f at the point a, f of a, in the form of y equals mx plus c. So we need to find the tangent, and then we need to find the coordinates of the point of intersection of the tangent to the graph at x is equal to a. So that's our answer to the first part. And the tangent to the graph of f at x is equal to 1 on a. So this second one is the intersection of two tangents. Righto, so let's do this first one. We need to find the equation of the tangent. Now, it is exam 2. We've got a formula here, so we can just use our CAS calculator to get us the tangent of the line. And to do that, we use our menu 4 for calculus, 9 for tangent line, and we put in the expression for the graph. So we're only going to put in the left-hand side for our graph. Now, when we do that, out comes the answer. And this is our answer here. Now, be really careful. Don't get too excited. This is our answer. Let's just make sure if we went and wrote down this answer as it is, right now I'm telling you this question's worth 1 mark, and currently if you write that you're getting nothing. Okay, the reason that you're getting nothing if you just wrote this is because, let's go back to the question and read the question again. It says find the equation. So an equation has an equal sign in it. All right, so we have to put y is equal to in front of that formula. And then the other thing it says right at the very end is blah, 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 in the form of y equals mx plus c. So even if we just whacked a y equals on the front here, this isn't in the form of y equals mx plus c. It's close, but our m is the coefficient of x. So our coefficient of x is in fact that bit there. There's our mx, and that is our c. So we need to make sure that we're double checking when we get all excited and write the answer down that it is in fact in the correct format. So it needs to be an equation, and it needs to be in the form of y equals mx plus c. So the answer that you actually have to write is y is equal to minus log to the base e of a of x. So that's the green bit that I had up there. Now, it doesn't really matter whether you write, so this bit here is the green bit up here. So it doesn't really matter whether you use the ln format or log to the base e. The people marking the paper will know that this is this and that they're equivalent. Okay, so just make sure if you're writing log to the base e that it is a subscript. See how mine's down a little bit? It's not the word loge, L-O-G-E, all right? So it's log to the base e of a of x. Good idea to leave these brackets in so that it's showing you that you're logging a, not logging a of x. Just a little technicality there. And then finally the plus c on the end. And so the final thing says, the final part says find the coordinates of the point of intersection of this tangent and the tangent to the graph at x is equal to 1 on a. So so we've got the equation of the tangent line here for the first part. We need to find the second equation for the other tangent, and then find their intersection points. So let's just have a look at what we've got here. So we've got the intersection point of two tangents. They're straight lines. One's a tangent at x is equal to a. The other one's x is equal to 1 on a. You don't need to write any of this in the exam. So we're going to do it using simultaneous equations. So here's what I did with my CAS calculator. Let's zoom in and have a look. So this is my original calculation from before. And then I copy and paste, or just go up and enter and change that a into 1 on a, and here is my second equation. And so what I want to do is I want to make these two equations equal to each other. So this is my first equation, and that is here. This is my second tangent line, that's there. And I want to take both of those, there, make them equal and solve for x. When I do that, I get this disaster of an answer over here. Okay. Now the question hasn't asked me for any particular format. So I would write this format down exactly as it is. Okay. I'd write it down exactly as it is. Then, if I had time in the exam to come back and tidy it up, then I would come back and tidy it up. At the minute, that is a correct answer, and I need to move on and find the rest of the question. So The question asked not for the x value where the two things intersect, but for the intersection point. So I need to have it as coordinates. So I'm going to take that x is equal to that disaster of a thing, and I'm going to substitute it into one of the tangent lines. Now it doesn't matter which one of the tangent lines I substitute in. So what I've done here is I've taken the second tangent line and I've equated it. See, this is my given that line here. Oops, undo that. This is my given that line, see right there? Given that, and then I just copied and pasted, whoops, that's a bit of a disaster today. I've copied and pasted my answer from up here. I just copied and pasted that down. And that gives me another disaster looking thing of an answer, but I'm just going to write that down. Okay, so I'm going to take those two answers and I'm going to write them down as they are. Okay, exactly as they are. So this here is my x value and this is my y value. If I've got time later, I will come and tidy them up. Okay, but at the minute I've got two correct answers. In fact, yep, I've got two correct answers. I'm missing a bracket somewhere. Where am I missing a bracket from? Here. I'm missing a bracket from here. Okay, so if I then had time in the exam to come back later and tidy it up, or if it said for it to be in a specific format, then I go through the process of simplifying. And if you look carefully at the bottom line, you'll see that this little bit in here appears over here as well. In fact, the whole of that bottom line is the same on those two things. So why don't I go ahead and try and simplify the bottom line on both of those? So I'll do that over here. And so these two logs here, log to the base e of a minus log to the base e of 1 on a, I can do as a division. So I can write it like this. So it's a times the natural log of a over 1 on a, which is a divided by 1 on a. So invert and multiply, which gives me a squared. The 2 comes out the front, and I end up with 2a natural log of a. Now, if I replace 2a natural log of a under here and 2a natural log of a under here, you can see I've got something I could rewrite this as a to the minus 1, bring this out the front and do some more tidying. So let's have a look at that. Okay, so over here, I've simply replaced this with this here, which gives me that on the bottom and that on the bottom. Okay, so now I can do some cancelling. So I've simplified this here to give me this as well. And so now I can cancel log of a, natural log of a here. The minus and the minus will make a plus, and I'm left with a squared minus 1 on 2a here. So I've got 1 on a plus, so this is our y value. Let me just square this up. So this is our x value, and now I'm working on my y value here. Okay, so if I rewrite these with common denominators, which I'll do, and tidy it all together, what I end up with is x and a. And if I used a different version, I had a different version of the y value as well on my CAS calculator printout, and it kind of looked like this. If I wrote both of these with the same denominator, you get this, and you can see it still simplifies down to the same thing. But as I said before, if you don't have to do this, don't do it. Leave your answer in the unsimplified form and move on.